This video demonstrates the current status of the Phalanx project, an asynchronous distributed array toolkit. Phalanx provides a Python interface to HPX, a modern parallelization framework for C++, and to Blaze, a high-performance C++ math library for dense and sparse arithmetic. Performance will be gathered in this demo by a tool called APEX, which stands for Autonomic Performance Environment for Exascale. This performance data will then be visualized using Traveler Integrated. The demo will also make use of the Agave framework, recently rebranded as Tapas by TAC. Agave lets us run code on remote systems, track progress and provenance, share data, and much more. When we combine these technologies in a Jupyter notebook, we call the assembled system JetLag. And now, a demo of the JetLag system. First, we're going to load JetLag and look at the various machines that are configured for our use. We're going to choose this one and initialize our setup. We can now submit jobs to that machine. The first job we're going to submit is a Fibonacci job, where the Python code is defined as follows. We're going to determine a random integer value as the argument for the Fibonacci function, and then we're going to use the remote run function from JetLag to submit it to the remote machine. The job wait command will wait for the job to finish, and as it runs, it will show the various status and stages of the job. When the job is finished, JetLag will automatically start trying to retrieve the job data when this command executes. Once it finishes, the visualization routine will provide us with a clickable link. The link will take us to a list of job outputs. There's only one job here currently, and that's the one we just ran. When we click on this Visualize button, we see various views of our program. We see our original Python code. We see the Faisal code used by the back-end system. This is sort of an intermediate or assembly language used by Phalanx. Finally, we see a graph of the execution with various lines of the code identified as nodes, and the amount of work that occurs at each node is color-coded. We also see how the individual cores are utilized on the target machine, which ones are busy and which ones are idle. We also see an overall map of the busyness of the system. But this isn't all we can look at. There are a number of other graphing possibilities within the Phalanx Traveler system, which you can see here. We can look at individual PAPI counters, for example, or we can look at percent of the system that is idle as a function of time. And any of these views can be closed or redrawn or maximized for better viewing. In addition to that, we can take a look at the history of the job as it moves through the system in Agave and what happened at each point. We can also look at the standard output for the job and the standard error for the job. We can also extract the job ID as understood by Agave, and we can use this at any time to retrieve the job results and graph them or analyze them in any way we like. If you prefer to see the Traveler output in the same notebook, that can be done with an iframe, as you see here. We can look at this web interface and pull up the same data. While this has the benefit of being inside your Jupyter Notebook page, there's much less visual real estate to work with. but everything works the same. Let's now consider another example. We're going to look at breast cancer data with the LRA algorithm. You can see that algorithm coded here. The NumPy instructions inside the LRA algorithm are automatically translated into Faisal instructions, and the equivalent operation is carried out. Here we read in the breast cancer data, we assign it to various variables, we print them out, and then we submit them. And again, we wait. Okay, the job is finished. Let's retrieve the output. Finally, you see the data in Traveler from the LRA demo. As before, we have the code in Python, the code in PhiSL. We have a breakdown of the computational nodes and the work spent in each of them. We have the total CPU time, the utilization view. We have the utilization of each processor, and we have the various other measures that Traveler tracks for us, such as the CPU idle. Thank you for watching.